I am going to discuss the basic programming of the CPU, Central Processing Unit. So basically we have the following four parts of the CPU. Inside the CPU we have the PC, which is program counter. Program counters was is to basically tells us that which program line is currently executing or which is the next line. After this we have the instruction decoder, which tells us the which program line which is executing, that which value is present at that executing line. And after that we have the ALU, arithmetic logic unit, which function is to perform all the basic functions inside the CPU, such as addition, subtraction, multiplication, and so on. After this we have the following registers inside the CPU. Registers function is to store the value in the CPU. Now our next slide is basically how computers work. On the left hand side you see that we have the CPU, Central Processing Unit, and on the right hand side on top you see that we have the memory block of the CPU, in which we have the following pins A0 to AN-1, which are basically the address pins, and D0 to D7 are our data pins. And after that you see that we have the WE, which is write, read, active low pin, and after that we have the OE, which is basically the output active low, and CS, this is the chip source, and chip source is connected to the logic circuit. When the logic circuit gives the low output, then we have the chip source enables. And on this you see that we have the following this, which is 0, 1, 2, 3 are the addresses, and you see that on each address we have the following value stores in the hexadecimal, which is, let's say that on the 0 address we have the 31 hexa, 1 on the C4 hexa, and similarly so on. So basically after that you see that on the right side top blue box we have the following code written, which I am going to explain. And you see that here we have the following 7 addresses, and next addresses are IO 16, 17, 18 and up to n inputs. So basically this tells us that when our first line is executing, which is means that which value is present on the 17 address, that value is going to store in the register A. So you see that, let's say we have the following, we have this address 17, in which we let's say that 9 value is present. So this 9 value is have to store on the register A. And you see that on the program controller we have the 1, which means that our first line is executing at this time. And instruction decoder is that on that address we have the following 0, because now our first line is executing, so 31 hexa value is present at that line. So on the first line, which is 17th address, value is going to store in the register A. And after that we have the following program line, which is that the value present in the register A is now have to store on the register B. So after this you see that our next line is that which value is stored in the register A. Now it has to move on the register B. After this we have the third command line, which is that the 6th address value is now going to store in the register A. So after that this functions perform that on the 6th address you see that we have the 5 hexa value. Now this 5 is going to store in the register A. After this we have the command, which is A plus B. Now the values that are stored in the register A and B is now going to sum through the ALU. Now arithmetic logic unit performs this function of sum. Now the answer of this sum is going to store in the register A. And after that we have the final command, which is that which value we obtain through the sum is now finally going to store in the 7th address. Now sum of 9 plus 5 is going to store in the 7th address. That is our final. Now this is the basic working of the computer. In this slide you see that we have the AVR CPU, in which we have the arithmetic logic unit, 32 general purpose register from R0 to R31, and PC register and instruction decoder. Now we'll see how AVR CPU is working. So first command we have the LDI, which is load immediate. So the format of this is LDI RD, K. LDI is the command which we are going to operate, means that we have to load the value in the register. RD is the number of the register, comma, then K. K is any value which is decimal, hexa, binary, so on. Okay? So we have the following example. Now LDI R16, 53 means that we have to load the value in the register 16, which is decimal 53. Its equivalent is equals to register 16 equals to 53. Now in this CPU we are going to store the 53 decimal value in the register number 16. After that we have another command which is LDI R19, hexa 27. Now this command means that we are going to store the hexadecimal 27 value in the register number 19. And after that we have the LDI R23, 0x27. Now we are going to store the 0x27 value in the register 23, and similarly LDI R23, 0 binary 111011000. So this is the loading values into the general purpose registers. After that you see that there are some instructions for doing arithmetic and logic operations such as add, sum, multiply, and etc. so on in the AVR's CPU. Add RDRS means that we have to add the value of RD and RS and store the sum of these two values in the RD register, which is equivalent to RD equals to RD plus RS. Now whatever value is present in the RD and RS is going to sum, and the answer is going to store in the RD register. So now we'll see the example, which is add R25 and R9. Which register is written first means that we are going to store the answer of sum in that register. Means that now we are going to sum the values of the registers 25 and 9, and then the sum is going to store in the register number 25. So basically this is the arithmetic calculation in the AVR's CPU.